Okay, so during the presentation I was going to pull out these samples of carbon fiber that are actually already cured. So they all have tape on them just for safety of handling. But this is a unidirectional, so it has only fibers in the zero direction. A couple fibers in this way just so that when you lay it up it doesn't come apart, but essentially it's all in this direction. And so you can see it's pretty, I mean it's still pretty weak in this direction, but it's way weaker in this direction, in the 90 direction. So as you can see it's pretty floppy here, and it's a lot stiffer in this direction, even with this much of an extra length. And then you have a multiply, so you have zeros, 90s, and zeros again, which is strong in the 0 direction, strong in the 90 direction, and a little bit weaker in the 45 direction. You can see it's a little bit harder to see, but essentially if you just move your thumbs around in a circle, you can tell that it's a little bit weaker in the diagonal directions. And that's because the fibers are only in these directions. Here's an example of that layup schedule. So that's basically 0 right here that I'm touching. Here's a 90. Right here, and there's another 0. So it's 1, 2, 3, and so you can get an idea of why the strength is along the fiber direction. The rest of it is just, trying to bend resin. And then here's a piece of plain weave. So you have a bunch of plies like this. So these are this one that you can see here is a 45, and there's another 45 on the back. So I think it's positive, negative 45, and then 1, 0, 90, and then another 45, 45. So it's 3 plies. You can see it's actually very, very, very stiff in the diagonal direction, again along the fibers, and not very stiff in the 0, 90 direction. So these are basically just samples of different carbon fiber that I'll show you that it's pretty anisotropic, it's orthotropic. Most of the properties are basically in some direction with the fibers.